Please see the description for timestamps. We're going to focus on rotations that are 90 degrees clockwise, 90 degrees counterclockwise, and also 180 degrees. We're going to first look at 90-degree clockwise rotations. And to start, we're just going to focus on rotating a single point 90 degrees clockwise about the origin. So what's really important is to first make sure you know how many degrees you're rotating, which direction you're rotating, and your center of rotation. So I'm going to make some notes that help me stay on track for that. So I like to place a point at my center of rotation, and I also like to just put an arrow around the 90 degrees or 180 degrees or however I'm rotating, just to remind me which way I'm turning, because sometimes it's easy to forget. So we're going to focus on rotating using the properties of rotations, and what that means is that when you connect your pre-image point, what you start with, to your center of rotation, and then the center of rotation to your image point, that should be creating your angle of rotation. In this case, it should be a 90-degree angle. So we have to force those two line segments to be perpendicular to get that right angle. So what I like to do first is to connect my pre-image to my center of rotation and find that slope. So I'm going to do that now. So the slope of this line segment is 3/1. In order to make sure that the line segment connecting the center of rotation to the image is perpendicular, I've got to make sure I have slopes that are opposite reciprocals. So the opposite reciprocal of 3/1 is -1/3. Reciprocals meaning you're switching locations of your numerator and denominator, so you're basically flipping your fraction, and then opposite means you're changing the sign. So we're going to start at our center of rotation, which is the origin, and we're going to go down 1 over to 3. And that should create our 90-degree angle. But it's really important that we make sure that that's rotating clockwise, because even though that does create that 90-degree angle, so would going up 1 and left 3. Do you see? You can both have 90-degree angles here. So it's really important to know which direction we're rotating. Because we're rotating 90 degrees clockwise, A should be moving down into the 4th quadrant. The other way would have been rotating 90 degrees counterclockwise. So let's fix this graph and show our location of A prime. So A prime is located at 3, -1. And again, you can make sure that you rotate it correctly by making sure you have the angle of rotation. So our center of rotation is the origin. If you connect your pre-image point to your center of rotation and your center of rotation to your image point, you should get your angle of rotation formed. So we got that 90-degree angle, and we also know that it's moving clockwise. That's how we know that we're correct. Make sure that with your image, you make sure to put the prime marking to indicate that it's the image. So now we're going to try a problem where we're rotating a shape instead of just a point. This time, we're rotating 90 degrees clockwise about the point -1, -5. So we need to make sure we plot the center of rotation and that we know which direction we're rotating. So I think that it's going to be easiest to rotate the point C, because if you connect C to the center of rotation, you have a horizontal line. And we know that horizontal and vertical lines are always perpendicular, and so that's going to get us that 90-degree angle. So then we have to just decide if we go over from C to this point, that's 1 unit. So C prime is either going to be from the center of rotation up here or down 1. And again, that's related to the direction we're rotating, which is clockwise. So if we're rotating clockwise, C prime should wind up 1 unit from the center of rotation. Next, let's rotate point A around our center of rotation at -1, -5. Again, we're trying to force us to have perpendicular lines. So we want to find the slope of the line segment joining A to the center of rotation. So we're going to just start at A and count down. So we go down 2, 3, 4, 5. So down 5 and right 2, 3, 4, 5. So the slope is -5/5, which does technically simplify to -1, but in the case of rotating using those properties of rotations, it's just easiest to not simplify. So we want to find the slope of the line segment that's perpendicular to that, and that's going to be 5/5. So we're flipping our fraction and changing its sign. So now we need to go over to the center of rotation, and we should be going up 5, 1, 2, 3, 4, 5, right 2, 3, 4, 5. And we need to make sure that this really is moving in the direction we want, which is clockwise. and that is clockwise. We can go ahead and label that A prime. And now we just kind of follow the same procedure, but for point B. So we need to find the slope from the center of rotation up to B, and then find that opposite reciprocal. So the slope from the center of rotation up to B is 5/6. So the slope of the line segment perpendicular to that is going to be -6/5. So we're going to go at our center of rotation. We're going to go down 6, 1, 2, 3, 4, 5, 6, and right 2, 3, 4, 5, and label that B prime. Again, we got to make sure that that's actually going clockwise, and in this case, it is. So all we have to do left is to connect our vertices, and you obviously want to be as straight as you can, using a ruler if needed. But as you can tell, this is going to be the same shape and size as the pre-image, and so that tells us that we rotated correctly, because rotations preserve size and shape of the pre-image, and we also preserve the orientation. So as we move from A to B to C, that's moving clockwise around those vertices. And then when we look from A prime to B prime to C prime, we're also moving around those points in a clockwise orientation. And so that's another way for you to verify that you rotated correctly. Now we're going to look at 90-degree counterclockwise rotations. And we're going to start again with just rotating a point, 90 degrees counterclockwise about the origin. So I went ahead and plotted my center of rotation. And I also made a notation for me just to remind myself that counterclockwise is moving to the left. And again, with the rotations, what we're doing is using that property that says that connecting this pre-image point to the center of rotation and then the center of rotation to the image point is going to form our angle of rotation. And in this case, we want to get that 90-degree angle. And because we want a 90-degree angle, we're going to have to make sure that those line segments are perpendicular. Perpendicular line segments are found by having opposite reciprocal slopes. So we got to start out by finding the slope from your center of rotation to your pre-image point. And so we're going down 2, left 2, 3. So your slope is -2/3. So the slope of the line segment perpendicular to that is going to be the opposite reciprocal. So we flip the fraction and change the sign. And so the sign is negative, so our slope over here has to be positive. This notation right here is just saying, indicating to me that it's the perpendicular slope. It's just a personal preference for notation. And so now we're going to start at our center of rotation, and we're going to go up 2, 3, right 2, and we're going to make sure that that really is moving in a counterclockwise movement, and it is. So we're going to go ahead and mark that as P prime. And as you can tell, when you connect your pre-image to your center of rotation to your image, you do get that 90-degree angle formed. So now we're going to rotate this triangle 90 degrees counterclockwise about the point -5, -3. So right off the bat, I see that C just so happens to be vertical to the center of rotation. And so that makes it really easy for me to be able to know where C prime should go. So I go down 1, 2 units to get from my pre-image to my center of rotation. So I know I'm going to have to go 2 units either to the left or to the right to make sure I get that 90-degree angle of rotation formed. And so we're moving counterclockwise. So as you can follow this pin, we're moving to the left. So we need to go to the left 2 units. So C prime should be located right here. So now let's rotate the point A. And in order to do this correctly, we've got to find the slope. And we can go from our center of rotation up to A. And that's going to be going up 9 units and right 5. And so the slope perpendicular to 9/5 is the opposite reciprocal, which is -5/9. And so we know that we're moving counterclockwise. So A prime should be somewhere over here, kind of in this second, third quadrant area. And so if we start at our center of rotation and go down 5, right 9, that's actually going to be a 90-degree clockwise rotation. So we have to think kind of opposite. The slope -5/9 means you can go down 5, right 9, or you can go up 5, left 9. And so in order to make sure that we're moving counterclockwise, we do have to go up 2, 3, 4, 5, left 2, 3, 4, 5, 6, 7, 8, 9. And we're going to go ahead and mark that as A prime to make sure that we know that that is the image. And as you can see, connecting your pre-image point to the center of rotation to the image does create a 90-degree angle. And then looking from A to A prime, we moved in a counterclockwise motion. And so now we just need to follow the basic idea here for B. So that's the location. Um,